All right, we are going to go ahead and look at this part of 6.3 in the 7th grade book. We are talking about speed, distance, and time. The first thing that I want to show you is that there are 3 different formulas to find speed, distance, or time. I'm going to write it over here on the bottom right. This is the speed, distance, time triangle. Distance is in the top, speed is on the left, and time is on the right bottom. Basically, what that means is that if we were trying to find the distance of something, you would take your thumb and you would cover up distance. What would be left would be speed right next to time. The S represents speed, the T represents time. Because of that, we know that to find the distance, which is what we covered, and we covered it because that's what we're looking for, that's what we don't know, then we can multiply speed and time. How do I know we're multiplying? It's because those two things are right up next to each other. When 2 variables or 2 numbers are listed right next to each other in math, that usually means that we are multiplying. So that's how I would do that. Now let's say, for instance, I wanted to figure out the speed. In order to figure out the speed, I would take my thumb and I would cover up speed. Why am I covering up speed? Because I don't know what speed is. That is the unknown. What I have left is distance, which is above T for time. What that means is when you see numbers or variables that are on top of each other like fractions, we know that that means divide. So distance over time, distance divided by time equals the way to find speed. And it would be the same thing if we were looking for time, then we would cover up time. So I'm just going to erase it so we can see that we don't know it. And we can see that distance is over speed. So we would divide our distance by our speed to figure out our time. All right, so this is a very useful triangle here. It's I personally find it easier to use the triangle than I do to remember the formulas word for word on how to find distance or speed or time when you have the other two. So here we go. I'm going to show you how to use it now. The first problem up at the top says Mrs. Hazel's arrow flew 600 meters in 20 seconds. What is the average speed? As an archer, I would love to know this, the answer to this problem. So here we go. I can go ahead and identify the important parts here. So for instance, my arrow flew 600 meters. Meters is a distance. All right, so I'm going to put a D over the top here for distance. And it says in 20 seconds. Seconds is a unit for time. So I'm going to put a T here. Now, what is the average speed? I'm looking for speed. All right, so if I came down to my triangle, I would cover up the S. I'm just going to erase it. And I could see that the only things left were D over T, or distance over time. Distance over time. All right, now I'm literally going to go in. Put my S back first. I'm literally going to go in and write the exact same thing using substitution for distance, using substitution for time. Okay, so the first thing I'm going to do is I'm going to turn distance into green. All right, so that I know every time that I see distance, it's going to be green. Every time that I see time, it's going to be blue. All right, here we go. So I'm literally going to write the same thing. I am looking for speed. Why? Because that's what we don't have. And I have the distance. It's written up at the top, 600 meters. I'm going to put an M for meters because that's the abbreviation for meters. over time. What is time? 20 seconds. All right. Now, what do I need to do? It is written like a fraction, which means we are dividing. The numerator, 600, is larger than the denominator, 20, so we are dividing. 600 divided by 20. All right, 600 divided by 20. Fun fact, I'm going to show you something really quick. If you have a 0 at the end of your problem, the end of your number, on the denominator and on the numerator, you can pretend they're not there. So my new problem looks like 60 divided by 2, which I know is 30. The average speed of this arrow is 30 meters per second. I can write it like this, or I can write it like this. 30 meters in 1 second. Easy peasy. All right, here we go. Mr. Foates Frisbee, second question. Mr. Foates Frisbee went 7 meters per second in 7 seconds. Should say 4 seconds, 7 seconds. How far did it travel? All right, let's identify what we have. So, first things first, I know automatically that, good grief, 7 seconds is a time. All right, I can already see that. Let's go ahead and figure out what else we have here. His Frisbee went 7 meters per second. Now, if it just said 7 meters, we would know that we were looking at a distance. But that's not what it says. It says 7 meters per second. Think of this like miles per hour. If you are talking about miles per hour, that makes me think of how fast my vehicle, or slow, is going. That is a speed here. Speed is going to be in pink. So 7 meters per second. All right, now let's figure out what we are looking for. The problem says, how far did it go? If you're talking about describing something with the word far, we're talking about distance. How far did you throw it? What's the distance you threw it? How far did you run? What's the distance you ran? So we are looking for distance, okay? So I'm going to write distance equals. If I come down to my triangle, I get rid of the D on the top. I cover up the D with my thumb. I am left with S for speed right next to T for time. Speed and time right next to each other. Remember, if two things are right next to each other, what does it mean? It means that you are multiplying. Speed and time. All right. Put my D back for the next one. Okay. So now I can go ahead and write this problem out using the speed and time that I do have. I'm looking for distance still. My speed is 7 meters a second. And I am multiplying that by my time, which is 7 seconds. All right, let's just look at the number values here. We want 7 times 7. What does that mean? Means we get to multiply. 49. And which of the two measurements are we going to write distance in? Am I going to write 49 seconds? How far did it go? It went 49 seconds. That's not telling us the distance. Meters, though, is the other increment of measurement that we're talking about. Meters, you can measure as distance. So this instance, it has to be 49 meters. That's pretty far. All right, next one. Let's look at this one. It says John Cena traveled 145 miles to get to Universal Studios from Stewart. He went approximately 58 miles per hour. How long did it take? All right, so how long did it take? I'm going to look at our question first. When I'm looking at something that says how long, the first thing that I would think would be distance. However, there's more to this question. How long did it take? How long did it take actually means the amount of time that was taken in trying to find this. So we know that we are looking for time. All right, so what do we already have in our problem? I'm going to cover up our T. What do we already have in our problem then? That means we must have distance and we must have speed. And if we look over at the triangle, when I cover up time, I am left with distance on top of speed. That means division. Distance over speed, distance divided by speed. All right, so I'm going to go ahead and rewrite my time over here. Okay, so let's go back to the problem to figure out what we have in there. I'm going to underline our question because I know we're looking for time. Let's find our distance here. John Cena traveled 145 miles. Well, that sounds to me like a distance. To get to Universal Studios from Stewart, he went approximately 58 miles per hour. Miles per hour, thinking of my vehicle here, how quickly I can travel, that speed of what I'm traveling. And that is 58 miles per hour. So let me set up our problem just like we did over here on the left. I'm looking for time. My distance I can plug in, that's the green part of 145 miles. And it's supposed to be over speed. And our speed is in pink, 58 miles per hour. All right, so we actually get to divide here. 145 divided by 58. I'll go ahead and tell you what it is. It is going to be 2 hours and then a half an hour. So 2.5 hours at that speed at 58 miles an hour to travel 145 miles. Remember, when you're using the distance speed triangle, that we need to cover up what we're looking for, what the question is asking us to find, and then we can figure out the rest of our formula, whether it's supposed to be speed times time, or distance divided by speed, or distance divided by time.